Here is a factoring review, and there are many videos listed in previous weeks on factoring. So the steps for factoring is first always check for your greatest common factor and see if you can factor out a greatest common factor. Then check if you have a trinomial, you're going to use a formula. Can you use a formula? And here are the three formulas that you would use for factoring. If you didn't remember your formula, it's okay. You can still use your trial and error or grouping method to factor. So then you would look and see, does your A value equal 1? If your A value equals 1, then you can easily do factoring where you factor the C value, find multiples of the C value that add up to the B value, and that helps you with factoring. Otherwise, you're going to need to possibly use trial and error or grouping. If you have 4 terms, just use grouping. And then finally, your last step is to check for the greatest common factor again. So let's take a look at a few examples. So here is example number 1. You have 4x squared plus 4y squared. And I noticed, hey, this does not factor. And the reason it does not factor is this is not the difference of squares. People get confused sometimes and think that that's a formula. The difference of squares, it is squares. These have square roots, but it's not the difference. Difference means subtract. So I cannot factor that. Can't do anything with it. Here's another example. If I have 6x to the 4th minus 16, actually this should say y to the 4th. So 16x to the 4th minus 16y to the 4th, well that gives me, this is one of my formulas, and so that is the difference of squares. So the difference of squares would be 4x squared plus 4y squared times 4x squared minus 4y squared. Then I look and I say, hey, I noticed I can keep factoring. This will factor again with the difference of squares. So this one will not. That stays as 4x squared plus 4y squared. But this, I notice, will break down into 2x plus 2y times 2x minus 2y. Here is a greatest common factor example. You have 2a cubed b plus 6a squared b squared plus 2ab. What can I factor out of each of these? So I look for the largest number that will factor out. That would be a 2. I look for the largest a value that would factor out. That would be an a. The largest b value that would factor out. That would be a b. So I can factor out a 2ab. When I factor out a 2ab, I look to see what I'm left with. Well, if I took 2a cubed b and I divided it by 2ab, I would be left with a squared. If I take 6a squared b squared and I divide it by 2ab, 6 divided by 2 gives me 3, a squared divided by a gives me a, b squared divided by b gives me b. If I have 2ab and I divided it by 2ab, I'd be left with 1. I can check my answer by taking this and doing distributive property. And when I do distributive property, it should take me back right to that. So my next example is a trinomial, and the a value is equal to 1. Remember, we look at ax squared plus bx plus c, and in this case, my a value is equal to 1, my b value is equal to 2, and my c value is equal to a negative 15. Well, when my a value equals 1, what I'm going to do is first I'm going to say, well, hey, list what times what equals x squared? Well, that's easy. That's x times x. So I make my two parentheses with my binomials in them. Then I am going to list the factors of c that will add up to b. So the factors of c that add to b. So the factors of c, which was negative 15, are negative 15 and 1, 15 times negative 1, 3 times negative 5, and negative 3 times 5. Well, the ones that will add up to b are negative 3 plus 5 will give me my b value, which was 2. So I know here I'm going to have positive 5 and negative 3. It does not matter which order I put that 5 and that negative 3. I need to make sure that the negative stays with the 3 and that the positive stays with the 5, but it doesn't matter if I have negative 3 here and positive 5 there. You can check your answer by foiling it back to see if it gets you back. Now let's take a look at another example, and this is a trinomial where a does not equal 1. And your book calls this factor by grouping. I call it the ABC method. So I have 2x squared plus 15x minus 38. First thing I'm always going to do if I have an a value here is look to see if I can use the greatest common factor and factor that out. Well, 2 doesn't divide into 15 evenly, so that's not going to work. So I'll list my a value as 2, my b value is 15. My C value is a negative 38. I am then going to go A times C, and A times C is 2 times a negative 38, and that gives me a negative 76. I list my B value, which is 15. I look for factors of negative 76 that will add up to 15, and it just so happens that 19 and negative 4 will multiply to negative 76, and they will add to 15. I will then take my trinomial, and I will rewrite it, replacing the 15x with the 19 and the negative 4. So I rewrote this as 2x squared minus 4x plus 19x minus 38. And when I decide where the 4x and the 19x go, is I take a look at the other numbers I have, and I see, you know, the 19 and the 38 go together nicely because I knew that I could pull out the 19. So that's why I decided to put the 19x here next to the negative 38. So then what I do is factor by grouping, and this is how we factor by grouping. Factor by grouping is when you have 4 terms. And when you have 4 terms, what you do is you cover up the last 2 terms, and you take a look at the first 2 terms. So I look at these first 2 terms, and I say, hey, what can I factor out of these first 2 terms? And I can factor out a 2x. And when I factor out a 2x, I'm left with x minus 2. Then I'll cover up the first 2 terms, and I'll take a look at the second 2. And I say, what can I factor out of the second 2 terms? And I can factor out a 19. And when I factor out a 19, I'm left with x minus 2. Now I take a look at all of this, and I say, hey, what's common? And that's an x minus 2. So I'll factor out an x minus 2. When I factor out an x minus 2, I'm left with 2x plus 19. And finally, we'll take a quick look at reviewing solving equations by factoring. So here's my equation, 2x squared equals 5x plus 12, and it says solve, because whenever we have equations, we're going to solve. This is a quadratic equation because it has a squared. Whenever we have a quadratic equation, these are the steps we follow. I'm going to take 2x squared, and I'm going to subtract 5x from both sides, so it moves the 5x to the left side of the equation. I'm going to subtract 12 from both sides because that moves that to the left side of the equation. And then I have set my equation equal to 0. And whenever we have a quadratic equation, we set it equal to 0. That's our first step. Our next step after we set the equation equal to 0 is to factor that. So we'll do a quick factor over here on the side, and this was a trinomial that had an a value that was not equal to 1, so I'm going to have to use that grouping method. So I list my a, b, my c values. A times c gives me negative 24. My b value is a negative 5. I need to find factors of negative 24 that add up to negative 5. That was negative 8 times 3. I then replace my negative 5x with negative 8x plus 3x, and then I factor by grouping by covering these 2 up, and I factor out a 2x from the first 2. Then I will cover up the first 2 and factor out a 3x from the second 2 terms. Then I look at this, and I notice I can factor out x minus 4 and 2x plus 3. So then I come back over to my equation, and I factor this to 2x plus 3 times x minus 4 is equal to 0. Well, now I can use the zero product property, and the zero product property says if 2 things multiplied are equal to 0, one of them must be equal to 0. So I set 2x plus 3 equal to 0, and I set x minus 4 equal to 0. I now have 2 linear equations, and I can solve those like we did way back in our first units. So when I solve this, I subtract 3 from both sides. 2x equals negative 3. Divide both sides by 2, and I get x equals negative 3 halves. Here, add 4 to both sides, and I get x equals 4.